Okay, we talk about the step function. Remember, using the step function the other night, and then we focus on the Laplace transform of the unit step function. Remember, there's going to be a base. C is a number. Okay, C is going to be a non-zero number, and this is the definition of the unit step function that we did it the other night. We just talk about we proved what is going to be the Laplace transform of this function. Okay, so we proved that the Laplace transform of UCT is going to be e to the negative. Okay, so this is the formula that we proved, and you have to memorize it. That's a Laplace transform of e to the negative UCT is e to the negative CS over S. Okay, and we are going to use it when you want to solve the equation. So we need the inverse. So that's the one. Then the other thing that we did, the last thing. So these are the examples that we did. The last thing that we did is we are going to have two types of translation, if you like. Your variable, you see the function f of t. Then sometimes you may have to change the t into the, okay, shift the t, if you like. T minus c. It's like when you do the graph. T minus c means, you know, you shift it to what? Shift it to the right, if you like, in this case. And so if you shift it to the right, we have this formula. The Laplace of UCT, f of t minus c would be e to the negative cs fs. And so this e to the cs is going to be related to this UCT that you have. So your function would be f of t. So what you have to do is you have to modify it into the f of t minus c, and the result would be the Laplace transform of your function. If it's going to be f of t, you can't do it. It's very easy to make this type of observation when the function is given to you. And equivalently, we are going to use the other way around, which is going to be the case. So we're going to practice this one. Okay, give you a couple of examples how we're going to operate this one. In this quiz, we are not going to give you, we give you this one to find, of course, but you are not going to have, the problem of differential equation containing this type of function. But of course, when we get to the test, that will be the second group of the differential equation that you're going to have. So let's see how we're going to. You have to provide that f t minus c carefully to be able to do this type of problems. Okay, so I'm going to give some examples related to this one, and then there is going to be another translation. The next translation is if you do it to the right. You see Laplace of f of t is equal to the f of s. If you change the s into the s minus a, then that would be another formula, and that will be so useful for you. When you want to use the Laplace transform, that would be because the rational function, remember the rational when the denominator is like calculus. When the denominator is factorable, you get the your partial fractions. But if the denominator is not going to be factorable, as in calculus too, you make you make a completing a square, and then you take care of it by the sort of a tangent inverse. It's going to be the same procedure over here. So let's practice on this one first, then we come back and we do the other one. Okay, so we want to find the Laplace transform of the following function. So you should expect the sum of them, or at least one of them, on your this quiz to practice. So let's start with this example. So we'd like you to find, find the Laplace transform, the Laplace transform of each function. When you are in application mode, these are the type of problems that you're going to face, of each function. So let's get the first one to warm up. Then we give you a little bit more involved one. The first one, the function is this one, f of t equal to the t minus 1. T minus 1, u1 of t minus 2 times t minus 2 u2 of t, okay, plus t minus 3 u3 of 2. You see, this is the function that you want to find the Laplace transform of this function. Okay, you know that Laplace transform is linear, so you have to find the Laplace of each of these solution. So this is the way we operate. We take the Laplace transform of f of t. It's going to be equal to the Laplace of the first one, Laplace of t minus 1, u1 of t, that's the first one, minus 2, Laplace of t minus 2, u2t, and plus the last one, the Laplace of t minus 3 times the u3t. Okay, that's one. Now, as we have this theorem, look at the above here. If you have a Laplace of anything other than the UCT, you have to make it as, you see the formula, UCT f of t minus c, to be able to do it. As soon as, because of the UC, you get the e to the negative CS. The rest is going to be Laplace transform of this function that you're going to see over here. Now, check the one that we have over here. You see, the first one. This is u1 of t. Since it's u1 of t, that would create e to the negative s. The rest, since it is 1, so you should have f of t minus 1. So if f of t minus 1 is t minus 1, what is f of t? That's it, t. This is f of t minus 1. If you add the 1, that gives you 1. So the function f of t is t. So this would be f of t minus c times uct. So the result would be what? The result would be e to the, okay, according to the formula, is going to be e to the negative cs, which is e to the negative s, Laplace of f of t. Your function is t. So you have to find the Laplace of t only. What's the Laplace of t? 1 over the square. So the final result would be e to the negative s over s squared. You see, this is the way you operate. If you manage it, that f of t minus 1, then you'll be able to continue. Okay? So once more, look at this formula. You should have f of ct, f of t minus c. This would be e to the negative cs times the Laplace of this function that you created over here. Now, if you compare it, you look at the base first. The base is 1, u1t. So this is going to be t minus 1. So f of t minus 1 is t minus 1. So what's going to be f of t? T. Okay? So the first one would be, this is going to be equal to the first one. Because of 1, you get e to the negative s. Laplace of what? Laplace of your function. Laplace of t. I write it down, then I do it. Okay, so f of t is t, because you got the t minus 1 here. Minus 2 times second one. The second one, you have u2t. Because of the u2, you are going to have what? E to the 2s, negative 2s. Negative 2s. Now the function. I write it down. This is the first one, then I do it. Okay, again, the function, if you can see, the function is f of t equal to t, because you change the t to the t minus 2. So that would be Laplace of the t. Okay, same one for the last one, minus 2. Okay, sorry, that what's the last one? Last one is t minus 3. So it's going to be plus e to the negative 3s Again, the function is just t. Now we find the Laplace of the t. So the first one is e to the negative s squared, because the Laplace of the t, minus 2e to the negative 2s s squared, plus e to the negative 3s s squared. That's the final answer. Because of all of them are s squared, you may write it down as s squared e to the negative s minus 2e to the negative 2s plus e to the negative 3s. So that would be the Laplace transform of the given function. It's easy procedure, but you have this was, everything was nicely given to you. But sometimes you may have to a little bit modification to create the function, the desired function, if you like, to be able to do it. I give another one. I change it a little bit so that you see it. Yes.
So why do we not need to worry about the minus c in all three of these functions, all three of these Laplace transforms?
Worry about what?
So you wouldn't. I thought we were going to take the Laplace transform of t minus 1. But
No,
instead we're just
no.
going to t.
Laplace of f of t. You see the formula?
Right.
The formula is f of s, which is Laplace of f of t.
Okay, so we just drop the minus.
Yeah, you have to go back to your function. You see, because over here, you see, you don't have f of t here. You have f of t minus c. If you have f of t minus c, you add the c to make it f of t. Then you find the Laplace of f of t, because this is f of s. That's a shifting, you see, you just shift it from the t to t minus c. So it must be matched, okay? The base and the t minus c must be match each other. Then you can quickly, okay, because of the u is e to the negative cs, the leftover Laplace of the function. Okay, that was the one that everything was ready for you. Let's see if you have to modify it. Yes.
A quick question. So you have like t minus 2v1, which is would your f of t function then be 1/2 t?
No,
No?
you have to modify it. That's the next one. Okay, that's a crucial one. Okay, very good question, but this is the answer. Okay, let's see. The one that I have is this one. Suppose your function is f of t equal to the t minus 3. Okay, t minus 3, u2 of t minus t minus 2, u3 of 2. That's interesting, you see. You have to modify it first. You see, because the base is 2 here. The base is 2, so you need t minus 2. Over here, the base is 3. So you need 3 minus 3. So you have to do a little of algebra, adding, subtracting to modify it first. To be able, otherwise you cannot do it. You see, you have to set the theorems. So how are we going to do it? It's easy to do. Just, this is your f of t. You see, because of the 2, you need what? You need t minus 2. So it's like, adding and subtracting. T minus 2 plus 2. And you already got the negative 3. It can be done easier, but I just show you in general. That is u2t. I simplify 2 minus 3, then that would give me t minus 2 that I need. Okay, it's going to be minus. This is u3. I need t minus 3. So this would be t minus 3. Then I add the 3 to match it, make it up. And the minus 2. u3t. But you can do it quickly, Now, what I'm going to do is, this would be what? This would be t minus 2 that I needed. That's what I need. The leftover would be a minus 1. Okay, it's like a minus 1. And this is going to be u2t minus, I need the t minus 3 here. So this is going to be t minus 3. The leftover would be what? Would be a positive 1 times u3t. What are we going to do next? We have to get rid of this extra term. Multiply. So what are we going to have? Is going to be equal to, it's going to be equal to the t minus 2. u2t minus u2t. You can find the Laplace of both of them. Next, minus t minus 3 u3t plus u3t. You see, those leftover are just ordinary unit step function that can be taken care of. And the leftover are just this translation that we know it. So we can do it quickly. This is our extra job. Most of the time it's coming with the trigonometric function. Trigonometric function, you know that. The sign, you can nicely put them together. Yes. Minus. Yes, you are right. It's going to be minus. Thank you. And this operation that I did, you can do it quickly yourself. Okay, but it's safe to add and subtract and just take it off. Now take the Laplace transform. Yes, that's a question.
Second step, t minus 2 times.
Distributed is a parenthesis. It's like multiplying a number times the parenthesis. You multiply the first one, minus multiply the second one. You see the top? We arrange it. This is t minus 3. We need t minus 2. So it's a t minus 2 plus 3. Then there is a negative 3 here. So I need the t minus 2. So the leftover, I add them together. 2 minus 3 is negative. Yeah.
Why do you need t minus 2?
Oh,
Or like to match the other one?
that's it. You have to match the base.
But the t minus 2 must match the other one, so you really need it to minus.
You see, if it's going to be t minus 2, you focus on the base. The base of the first one is 2. So you need t minus. The base of the second one is 3. So you need t minus 3. Okay? So you have to match the base to be able to apply that here. Okay? Let's go. Now the Laplace transform. What's going to be the Laplace quickly? Laplace of f of t. Let's see if that you can do it quickly. Anyone want to try the first one? First, e to the base. Negative 2s. You see, this is just Laplace of t, because we make it into t minus 2. Laplace of t is what? 1 over s squared. That's the first one. The second one is ordinary unit step function minus e to the negative 2s over s. That's a 2, e to the negative cs. Remember, e to the negative cs over s. Formula. Laplace of uct is e to the negative cs over s. You know, the one that we prove and we have it. You can check it. Okay, we are here. Next, minus. The base is 3. So it's going to be e to the negative 3s. The function is t. Laplace of t again would be 1 over s squared. Leftover minus the base is 3. E to the negative 3s, okay, over s. That's it. We can just only put them together, you know. Yes.
So for the negative CS, for the second U2 and the minus U3, why is C not just 1 in that situation?
C is not 1 because the C is the base. The base is 2, the base is 3.
Oh, Okay.
because we cannot change the base.
Yeah, I was thinking C was the T is.
No,
whatever we're
no.
subtracting.
You
Okay.
see, yes,
If our f of t minus c was positive, like t plus two, you wouldn't be able to use the formula.
we can.
Would it?
In this case, we assume that the C is positive. So you see it would be negative two, but the base is always a positive number. It's like, the log function, for example. Remember, yeah, when we define it, remember when we define the unit step function, we assume that the C is a non-negative number.
Oh, okay.
C is always positive.
Hmm.
Otherwise, everything would be changed. Okay, a little bit of simplification, usually, that would be nice. You can leave it, but you can put these S squares together. Okay, so you can write what? E to the negative 2s, e to the negative 2s, e to the negative 3s over s squared. And just put those s's together. So it's going to be negative, if you like, e to the negative 2s. And minus, I can't do anything about it. This is the one. So that's the most you do for us, okay? Just modify it. Otherwise, it's yes. It doesn't matter. It doesn't matter. We did the job. Okay. So so this is the way we are going to operate with this transformation that we're going to have, or translation for the functions. Okay. You will see it when we want to solve a differential equation. It's coming with the sine, cosine in application problems. Okay, and we're going to do it. So I'm going to give another one to see. This next one is also nice. Okay, so it's not going to be all the time everything nicely given. You have to modify it yourself to be able to apply this formula. Okay, let's give another one. This is going to be a combination of two actions that we did before. Let's see if you remember. So that was number 3. How about the piecewise defined function? You have the different choices for this one, of course. Let's try this one. F of t is equal to this function. The function is 0 if t is less than 2. And it is t minus 2 squared when t is greater than or equal to 2. You want to find the Laplace transform of this function. Of course, it's a piecewise defined function. You can use the definition to find it. Remember, you can go from what? You can go from 0 to 2, 2 to infinity, but you end up with integration like, you see the one? So, you just apply the integration by parts to find it. But we want to find this idea. Remember how we're going to change this one into the unit step function? We did it the other night. Yeah, factor out, yes. We factor out t minus 2 squared. Solution. You say, oh, it's like f of t equal to. It's going to be t minus 2 squared. Like multiplied by this function, if you like, 0, 1. T less than 2 and greater than or equal to 2. But we know this function. Okay, that's a unit step function at base 2. So this would be equal to, so you have f of t equal to the t minus 2 all squared u to t. You see, everything is nicely given here. The base is 2, the function is t minus 2 squared. So the actual f of t would be t squared, and for the rest, you have the base. So everything is already given to you, okay? So Laplace of f of t would be equal to, you see, it's a Laplace of t minus 2 all squared u to t. So this is going to be equal to what? You have the base is 2, so e to the negative 2s. Laplace of what? You see, you drop the 2, is going to be Laplace of t squared. What's the Laplace of t squared? It's going to be 2 over
That's cute.
one up, yes, s cubed. That's it. So it's going to be 2e to the negative 2s s cubed. You see, very easy. You better do it right away. Otherwise, you have to go to do integration by part twice. Yes,
In the last example, when you were finding the Laplace with the step function, you put it over S. Right, you just needed a negative two.
yes,
Over S, what is that S on there?
no. If you have a unit step function by itself, this is not a unit step function. Okay, this is a combination of f of t minus 2, u 2t. In that one, we have to modify it so there was a leftover. Okay, so this is the way you are going to use these functions, if you like, to get these numbers. Okay, any question? Yes,
So do you mind if we find the efficiency separately on the side and then put it back?
no, that's fine. That's fine. This is easy, just be doing it. That you don't worry. You're going to have the one that you have to do it separately.
Uh-huh.
Okay, the last one. You may like this one, or you may not. Okay, let's see. F of t equal to, I just want to see, there is something about it. I want to see if you can get it. T less than 1. This is t squared minus 2t plus 2. I think it's in your review. That's the function. Again, of course, if you want to go with a straight definition, it takes time. You have to do a couple of integration by parts to be able to do it. So try to change it to the unit step function. It's easy because we got the 0 on the top. We take this one out, automatically you get the what? U1t. So the solution would be, solution f of t is equal to, I'll just explain it, t squared minus 2t plus 2. The function is 0 for t less than 1, and it's 1. Okay. 1 for t greater than or equal to 1. So the leftover is unit step function at base 1. So f of t would be, it's a t squared minus 2t plus 2 times u1t. So your unit step function is u1t. So you have to make a function of, of the variable in terms of the t minus 1 to be able to do it. Any suggestion for this one? Yes,
Simplify that one?
of course. What do you mean by simplify?
It's where t minus 1, right?
You need t minus 1. Yes, somehow. You see that's 1? It's a t squared minus 2t. Remember, t squared minus 2t plus 1 would be t minus 1 squared. Then you can get the function and then you go in. Okay, so the hint is this one. Since the base is 1, you have to make this one as a function of t minus 1. T minus 1. So the other, you see, we look at this one, we change it. So this is how we do it. It's going to be f of t equal to, we write this one as what? T squared minus 2t plus 1. That was 2. We got the 1 here, so the leftover would be 1 again. You see? Because 1 and 1 would be 2. But this is the square of what? T minus 1. So that gives you t minus 1 squared. T minus 1 squared plus 1. Times it by u1t. So this is of the format that we are interested in. Any question? So sometimes, you know what you are looking for. You are looking for u minus 1. So it's a t squared minus 2t. Quickly, we realize that, we can make it into the perfect square. So when you find the Laplace transform, u1t would be e to the negative s. What is the function this time? What is f of t? This is f of t minus 1. So the function would be
square minus.
T square? No, where is the two t? This is t minus one. You call this one z. So it's a z square plus one. So your function is t square plus one. Because you shift it. You see, you change the t to t minus one. That's one. So it's a t minus one, your new variable. You see, you call it z. So it's a z square plus one. When the function is z square plus one, it's c square plus one, a square plus one. Okay, so the function in this case is t squared. So the Laplace is going to be what? So the Laplace of f of t, I write it down so you know what's going on. For this one is going to be e to, no, this is u1. E to the negative s, Laplace of what? The function, t squared plus one. Your function is t squared plus one, that you change the t to the t minus one, you get t minus one squared plus one. So that is your function. Now we can find the Laplace of a t squared plus the Laplace of one. So it's going to be e to the negative s, Laplace of f of t, Laplace of t squared is what? 2 factorial, which is 2 over s cubed, and the Laplace of one. What's the Laplace of one? 1 over s. Because one is t to the 0. Okay, that's it. So it's a 2e to the negative s square s cubed plus e to the negative ss, the final. These are all the possibilities. When you do a couple of them, it's not difficult. When you do the couple of them, you get the idea that what you are looking for, and you get it. Yes. You see, your function here is what? F of t minus one is t minus one squared plus one. You are looking for f of t. You see, the function is just a machine. You see, this function is f of a box is equal to what? Box squared plus one. It depends what are you going to drop into the box. If you drop t minus one into the box, would be t minus one squared plus one. If you drop the t into the box, would be t squared plus one. You see, that's definition of a function. Function is an action. You drop the input, you get the output. So this function, the action of this function is what? Square the input plus one. Because you see, this is f of t minus one. F of t minus one, you see, look at this one. F of t minus one is t minus one squared plus one. Change this one into the box. F of a box is box squared plus one. Now drop anything you like into the box. If you like t, that give you t squared plus one. If you drop b, give you b squared plus one. This is the way you find all of these functions. As soon as you get a t minus one. Yes.
Wouldn't you be able to do the same thing by doing the Laplace of t squared u1 t plus the Laplace of u1 t?
Good luck. So what are we going to do next?
Isn't that the same thing?
No, it's not the same thing because you don't have that theorem. Remember, your theorem is what? Because it's not by it's no. If you multiply together, then you have eventually you may be able to do it. But it takes so much time because you have to modify all of them. Remember, your base is one. Your base is one. You can only do it if you have something as in t minus one. That takes time. I know what you mean. Because in you have to change what? T squared 2 minus 1. Then what? If you want to change t squared t minus 1, you have t minus 1 squared, you have to do quite a lot of algebra. No.
I just thought this kind of
No.
like the same way.
No, it's not the same. You'll be in trouble. So the quickest way to do it is make it as a t minus one, okay? They arrange, of course, it's not the case that all the function would be nice, that. But they arrange it so that you'll be able to do it. So you have to find the path quickly, that's why. Otherwise, yes, there are some other. Okay, so that's the case, yes.
I have two questions.
What's the second one?
Can you just like, you know how you have t minus one squared and then you end up with t squared plus one? Can you just like multiply t minus one times t minus one, you end up with the same thing, but this is a faster method?
No. The definition of a function. That's what you do. You see, you have a function, and as I explained it over here, you see?
Yeah.
Your function is what? F of t minus one is t minus one squared plus one.
Is it always squared?
Your function is a square. Okay, we're talking about this function that you have. You see, it's a machine. It's a machine. The formula for your machine is what? F of t minus one is t squared plus one. F of white mocha is white mocha squared plus one. It doesn't matter. You call the white mocha t. F of t, t squared plus one. You see, the function, in the case of the function, notation is not important. The operation is important.
How am I gonna figure that machine on my own?
It's not your own,
And then on
it's
the
given
test,
to you.
or the homework,
Hmm?
like on the homework.
Notion of a function. This is a preliminary concept of algebra.
Oh, that's always the case?
It's algebra,
Oh,
yes,
okay.
that's the
always
one.
been a problem. Okay, I have one more question, please.
Yes,
For the t's, you got. Oh, you got t squared minus two t plus one and then plus one. You got the plus one because you get t minus one squared.
that's it. Yes, yes. They arrange it so that you get this one. Otherwise, we'll be in trouble. Okay, we are ready for it. They may give you t squared minus 2t only. You see, if they give you this one, you add and subtract. You get that number. Or you can create whatever you like first, you see. You say, oh, I like t squared minus 2t plus one. Add and subtract, you see, to get these numbers. Yeah, it's a new operation. It takes a little bit time, okay, to be able to take care of it. Okay. This is the direct one. Let's do it the other way around. If a function is given to you, how are we going to find the Laplace inverse? Because when we do the, when we do the differential equation, this is the other way around that we're going to be interested, okay? So let's quickly give you one example of the other way around so that we'll be able to do, because I want to give you one more, one more equation. Are you ready? Let's give you the other way around. You see, as you can see, it's such an important, real and interesting operator, this Laplace transform. And this is just the beginning. We can do so much with this, this nice function. Okay, are you ready? The other way around. So a function, a Laplace transfer would be given to you, you want to find the function. So example, find the inverse. Okay, find the inverse. Inverse Laplace transform, okay? Laplace transform. So we want to do it the other way around, okay? So this is going to be the function. I just pick one of them, Laplace transform of the function. Okay, of the function. For example, this is let's try this. F of s is equal to 2 e to the negative 2s, okay, over s squared plus, let's say plus 4. So the Laplace transform of one function is given to you, you want to find it the other way around. As soon as you see this, okay, this factor of e to the negative 2s, that gives you the indication that you have to use these what translation theorems. Okay, you see this is going to be the case solution. So you want to find the Laplace inverse of this function f of s is equal to what? And this is it, the Laplace inverse of 2 e to the negative 2s over s squared plus 4. You know that 2 is a number, you can keep it on the top or can put it down. Because of e to the negative 2s, you are going to have what? u2t. What should be the rest? No, in general, f of t minus 2. You have to find f of t first. What is the function? 2 over s squared plus 4. What is the Laplace inverse of 2 over s squared plus 4? It's not cosine. No, no, sine. If there is a s on the top, it's cosine. There is no s on the top. It's a sine. It's a sine of 2t. Okay? Sine of the 2t. But you have a translation here. So you have to find the sine of what? 2t minus 1. It's going to be, let me write down for you. Okay. This is your formula. u2t f of t minus 2. That's your formula. But I just explained it. You see the leftover is this one. This is the leftover. Laplace inverse of the leftover is what? Sine of the 2t.
So isn't that an A on top, not an S on top,
No, it's 2. It's not s.
which is A, right?
Yes, it's a.
So is it A over S squared plus 4, is that the inverse of that? I thought that was cosine.
Is it? No, s on the top is cosine.
Oh, okay.
It's 2 on the a over s squared plus s squared plus a squared. Check the table.
Okay,
It's sine. Okay, it's a sine of 2t. But since you have this translation over here, you see, what you do is you change the t into the t minus 2, if you like, to understand it. This is the way we do it. If you change it to the t minus 2, that give you what? That give you f of t minus 2 that you are interested in. So f of, we do it right away. But f of t minus 2 would be sine of 2 times t minus 2. So if we go back, you got it. Laplace inverse of fs is going to be equal to what? u2t sine of, we usually write it down as is, just to show that you know the form. Or you can multiply, but we don't usually do it. So that would be the Laplace inverse of this function. It's very easy to find out this because of that coefficient that you have, e to the negative cs, okay? Anytime you see the e to the negative cs, this is translation problem. So you find the Laplace inverse of the leftover, but remember, you shift it. You shift the t to the t minus c. In this case, it's going to be t minus 2. It's optional to write it on sine of the 2t minus 4 if you want it. Any question? Give me another one. That's it. I can give you 1,000. Okay? Right? It's fine. We have to get these application problems. You see this type of just give you the good news. You are going to have one differential equation, and you have to do a couple of days when you want to solve that equation. Okay, it takes time. That's why we practice, so that not on this quiz, of course, it would be too much.
Are we doing a quick review?
Of course. That's it. Let's make the preparation first. Okay, how about the next one? Let's see if we can do it. Are you ready? That's it. Fs equal to, you see, it's very easy to make these questions. Whatever we have before, we multiply by e to the something. Okay, that's it. So how about negative 2s again? But this is s squared plus s minus 2. Let's see if you remember this one. Again, as soon as you see e to the negative 2s, it's translation. So you are going to have u2t. You have to find the Laplace inverse of what? 1 over s squared plus s minus 2 first. When you find that, we change the t to the t minus 2. How are we going to find that?
Are you gonna use partial fraction decomposition?
Of course. Okay, very good. So let's write it down. Laplace inverse of Fs is going to be equal to what? I'll just repeat the formula first. Okay, e to the negative 2s, s squared plus s minus 2. Remind yourself that you are going to have u2t f of t minus 2. So your job is to find f of t. Okay. To find f of t, we have to find the Laplace inverse of the leftover first. Okay, you have to find the leftover Laplace inverse of the leftover first. Then you change the t into the t minus 2. Yes, you have to use the partial fraction. So let's do the partial fraction. It's 1 over s squared plus s minus 2 factory. Give us the numbers to factor. Numbers. S plus 2, s minus 2. The top one, break it. That's it. You know that. A1 and A2, if you like, on the top, or the shortcut. Remember the shortcut? There is no S here. So I start with the 1 and negative 1. I check it to see if I got it. Cross multiply, that give me S minus 1 minus S minus 2. That would be simplified. The result would be negative 3. But I want 1. So divide by negative 3. So this would be over negative 3, and this would be over negative 3. So that give you what? That give you negative 1/3. S plus 2, and negative positive, plus 1/3 over S minus 1. Okay, that's very easy. Most of them are okay. But unless you know it's complicated, you go with the A1 and A2, that's you do the partial fractions. Okay, now we can find the Laplace inverse. So what's going to be the Laplace inverse of 1 over s squared plus s minus 2 is going to be Laplace of the first one. I don't need that negative 1/3. I pull it out. Laplace inverse of 1 over s plus 2. Okay. Plus 1/3 Laplace inverse of 1 over s minus 1. You know that they are going to be e function. So it's going to be equal to the negative 1/3. The first one, e to the negative 2t plus 1/3. The second one, e to the t. This is your f of t. But remember, the base was what? The base was 2, and you need f of t minus 2. So replace t minus 2, go back and substitute it here, and then you're done. So what's going to be f of t minus 2? It's going to be negative 1/3. E to the negative 2 times t minus 2 plus 1/3 e to the t minus 2. We can simplify it a little bit on the top, then go back and substitute and do that. Negative 1/3 e to the, or leave it as is really, we accept it. Negative 2t plus 4 plus 1/3 e to the t minus 2. So the final answer, you just multiply by u2t. Laplace inverse of f of s is going to be equal to, remember, u2t times this function. Negative 1/3 e to the negative 2t plus 4 plus 1/3 e to the t minus 2. So that gives you the final answer. Okay, when you do a couple of them, quickly you do the operation right away. Okay, there is going to be another translation. I wanted to talk about that one too, but we leave that one after your quiz. We're not going to lose anything, okay? The other one is much easier, of course. But, we leave it. There are two more properties that will make it easier for us to find the Laplace transform. Because we want to avoid the definition 0 to infinity. So you collect all of them. You need two more theorems to be ready for it. But we'll talk about it after the quiz. Okay, I can give a short break now. Come back, I do the review. That's about it.